Hello viewers, welcome to the session on holdout cross validation in machine learning. Please make sure to watch all the prerequisite videos for your clear understanding and to make best use of it. Holdout validation is probably the simplest validation method as it splits the available sample into two groups, training set and testing set. The training set consists of the majority of the available samples and it is used for training the model, while test set corresponds to a smaller percentage of the available samples and is used in order to evaluate the model's generalization ability. However, excluding a portion of the dataset can be costly when the available samples are few. So we need to be careful, and moreover the results obtained greatly depends on the random splitting of the dataset into training and testing sets, and the observed results are generally unstable and can be misleading if both splits do not reflect the structure of the original dataset. Generally, holdout validation should only be used in practice if a very large number of samples is available. And to counter the drawbacks of the simple holdout method at the expense of computational load, other validation techniques have been proposed and we are going to look into it in our upcoming videos. So let us suppose this is our whole data set, and the main job of holdout cross validation is to assign a major portion of the dataset for the training of the model. So it will split the dataset into two parts, training set and testing set. Majority of the portion will be given to the training set as we want our model to be trained thoroughly, and a small portion of the dataset is preserved for testing or validation. So our model is trained over this whole training set, and then we predict and check our accuracy through testing set. Now let's straight away jump into your favorite hands-on session on holdout validation in Python. So I'm importing all the important libraries, and then from sklearn package we are importing the datasets in which the very famous iris dataset can be found. So now I'm loading the dataset iris dataset to dataset.load function. See, it has been executed successfully. Now let me show you. And after that, from the whole iris dataset, I am segregating the dataset into independent and dependent variables. See, it has been executed successfully. On the basis of this independent data, let me show you this. These are the lengths of the flowers and dimensions of the flowers, and on the basis of these dimensions we are going to predict whether which type of flower it is. There are three types of flowers, so it has been classified accordingly. See, 0, 1 and 2. Now our job is to segregate this whole data set into training and testing set. So now in this method we are going to use holdout cross validation, which is also known as train, test and split cross validation. So let me explain you this chunk of code, the main chunk of code of holdout cross validation. Here from sklearn library we are calling the model selection module and importing train test split class, and the train test split will split our dataset into four components, that is x train, x test, y train and y test. X is the whole x dataset will be segregated into training set and test set. Similarly, whole y will be segregated into training set and test set, which we have defined that test set should be, let me just write here x and y for your easy readability. We have passed the independent and dependent variable right here, and then I have defined the test size as 20%, which means 80% of the 150 will be used for modeling our algorithm, training our algorithm. So let me execute this chunk of code. See, it has been executed successfully, and you can see here that earlier our dataset independent variables were containing 150 rows, But now, after splitting it into training and testing model through holdout cross validation and giving 80% to the training set, see it is now containing 120 rows. So this is the concept of holdout cross validation, and 20% of the 150, which is nothing but 30 rows, are in the training set. Similarly, the corresponding dependent variables values for this training set is in y, and for this x test is in for this x train is in x train, y train, and for this x test is in y test. Okay, after that, let me just show you how we are going to implement this in support vector classifier. Just I am executing this chunk of code to calculate the score. See, our model has predicted 100 with 100% accuracy. And as usual, I have included code snippet for your quick revision, so you can pause your video right here and can take the screenshot of the same for your future reference. I hope this video proved fruitful to you and hope you have gained something extra than what you were knowing earlier. Thank you.